Okay, welcome back, and now we're going to talk about the derivatives and the shape of a graph. Okay, so before we talked about using the derivative, we said that, or critical points, we said that a critical point, there might be, if there are extrema, they're going to happen at critical points. But just because you have a critical point doesn't guarantee that there's an extreme value at that point. For example, with the y equals x cubed that we talked about before, there is a critical value at x equals 0, but the function is an increasing function on its domain. So it turns out that there is no critical value at x equals 0. So the question then is begged, how do we find extreme values, right? How do we find those max and min values? Well, the corollary 3, kind of gives us a way of doing that. Remember, in corollary 3, it said that if the derivative of a function is positive over a interval, then the function is increasing over that interval. And also, if the derivative is negative over an interval I, then the function is decreasing. So now we can use that to help us, because if we have a continuous function, right? So if we have a continuous function over I, right? That contains C, right? Let's see something like this. Okay. And we have this graph. Well, if it's a continuous function, then the only way that we could have a maximum value, right, is if the derivative, right, goes from, if the function goes from an increasing function to a decreasing function, right? Or it's a minimum value if the function goes from a decreasing function to an increasing function. Okay? So a continuous function f has a local maximum at point C. So let's say point C, right? If it goes from an increasing function to a decreasing function, and a continuous function f has a minimum if it goes from a decreasing function to an increasing function as it goes through point C. Now, if we have a function that's continuous over an interval, right, and is also differentiable over that interval, except possibly at C, the only way you could have f switch from increasing to decreasing, or vice versa, at point C is if the slope changes signs. If the derivative of the function changes signs as x increases through C. Now, if f is differentiable at C, well, guess what? If f is differentiable at C, then the only way that that would happen is if f prime of C is 0. Right? Because if we have a continuous differentiable function, right, and we have a critical value at C, and it's defined at C, right, and the derivative exists at C, right, that's what I'm saying, then the only way that you could go from, for example, f prime of x being greater than 0 to f prime of x being less than 0 as you go through C is if f prime of C is 0. Okay. So what does that mean? So that means that we can conclude that for a function f that is continuous over an interval I containing C and differentiable over I except possibly at C, then the only way f can switch from increasing to decreasing or vice versa is if f prime of C is equal to 0 or f prime of C is undefined. Okay? And so that gives us something that we can use to help locate maximum and minimum points. And that's going to be the prelude to what we're going to call the first derivative test. Okay? So the takeaway here are these three. So first, okay, so the first thing is if a continuous function has a local extremum, either a local maximum or a local minimum, it must occur at a critical point. So that we know from before, but it bears repeating. So we'll call that critical point C. The other thing is the function has a local maximum, the function has a local extremum at a critical point C if and only if the derivative f prime switches signs as x increases through C. So that's what we were just talking about. So this is my, this is shorthand for if and only if. Okay, so the function has a local extremum at the critical point C if and only if the derivative f prime switches signs, so that means either goes from negative to positive or positive to negative, as x increases through the critical point C. Okay, so that's another result. And the final result is to test whether a function has a local extremum at a critical point C, we must determine the sign of f prime of x to the left and to the right of C. Okay, and so that result comes from these two. Okay, so again, the only way, in fact, let me write it down up here so you can have it in your notes. So this would be, let's make this number 1. This would be number 2, and we'll put number 3 up here. So it says, so this is like the conclusion from 1 and 2. So to test whether a function has a local extremum at a critical point C, we must determine the sign of f prime of x on the left and right of C. And that's it. And this result is called the first derivative test. Have a great day.